We now return to parabolas with a different perspective of the same shape that we used to do. Parabolas are the first type of what we call conic sections. These are sections of cones found by taking two cones, putting them together, and taking different slices through it. If you look at the image here on the right, we have a slice of a cone. It's actually of a single cone that is taken by taking a plane and slicing it through on the side, and we get this shape that we've called a parabola. Mathematically, parabolas are the set of all points that are equidistant. Again, that means the same distance from, equidistant from a fixed line. This line is called the directrix. And a fixed point that is not on that line, and that's called the focus. So if we look down, basically we generate a parabola by drawing a line, horizontal or vertical. In this case we have a horizontal line that I'm trying to trace, and we have a focus right here. Let's pick an arbitrary point on this parabola, like maybe a point out here. If I were to connect a line from the focus to that point, it would be the same distance as from that point directly down to the directrix. Those would be congruent. Truly every point on a parabola is the same distance from the focus as it is to the directrix. Now, from a point to a point, you draw a direct line, but from a point to a line, like you see here, we draw it perpendicular to get the shortest possible distance. So that's where this comes from. And clearly you can see that we have a distance here and a distance here that are both congruent. So that's the essence behind a parabola. Let's look at these different parabola parts a little bit more closely. The focus is, strictly speaking, it's an ordered pair that is always inside the parabola, and it lies along this axis of symmetry. You can faintly see that in the notes. I think you can see it better on your page. But an axis of symmetry is a vertical line that passes through the focus and the vertex, creating a mirror image on the left and right side of the parabola. We call this an axis of symmetry. The vertex is a point halfway between the focus and the directrix, and it lies along the axis of symmetry. We've known what a vertex is for a while now. It's the maximum or minimum of a parabola. But now we kind of expand that. It's halfway in between our focus and directrix. A vertex being halfway is also the midpoint of the segment drawn from the focus that is perpendicular to the directrix. This is the segment up here that we're talking about. I'm kind of coloring it darker in orange, and the vertex is the midpoint of that. Finally, the directrix is a line. It is always located out of the parabola, or outside of the parabola. So if I kind of draw a point and a line, and I draw a parabola wrapping around, this is the directrix. It's always outside of the parabola. The parabola never crosses the directrix, and it's either a vertical line, which we know all x equals are vertical lines with undefined slope, or a horizontal line, y equals, with a slope equal to 0. The axis of symmetry is the line by which the parabola is symmetrical. And we can also say reflected on itself. But it's symmetrical. The line of symmetry passes through the focus, the vertex, and is perpendicular to the directrix. So if the directrix is in x equals, the axis of symmetry is a y equals. If the not y equals 1, just a y equals. If the directrix is a horizontal line, a y equals, then the axis of symmetry is an x equals. Moving along, we have C. This is new. We're going to take this little letter C and we're going to reserve it. It is designated as the distance from the focus, from the vertex to the directrix, or from the vertex to the focus. One or the other, it's the same distance. We know that 2c is the distance then from the focus to the directrix. So if I go right all the way back up to my diagram here, I see that, let me kind of erase some of this stuff. C is going to be this distance here and this distance here. It's the distance from the vertex to the focus, and it's the distance from the vertex to the directrix. Okay, move back down. We now have the distinction between two different kinds of parabolas. We have the vertical parabolas that we've always done before. Those come from quadratic functions. And those equations are y-equals equations. Those equations, strictly speaking, are y is equal to a times x minus h squared plus k, where the vertex is at the ordered pair h comma k. If a is greater than 0, meaning a is positive, then this opens up. And if a is less than 0, meaning it's negative, then it opens down. So up parabolas, down parabolas. Furthermore, we know that C, this distance from the focus to the vertex, or from the vertex to the directrix, C is defined, and this is something you're going to have to remember too, is defined as 1 over 4 times the absolute value of A, or just 1 over 4A. This also means that A is equal to 1 over 4C, strictly speaking the absolute value of C, but this helps us kind of relate C and A and C. Both of these two equations are equivalent. So remember the C equation, and we'll be good. Okay, let's look at horizontal parabolas. This is going to be new. A horizontal parabola is defined as an x equals. It is x equals a times y minus k squared plus h. And you should be able to see the symmetry of this. The vertex is still h comma k. And if a is positive, then this opens to the right. I know this isn't a function, but that's okay. And if a is less than 0, meaning a is negative, then it opens to the left in the negative y direction, or negative x direction. C is still 1 over 4a. So we're going to do some practice of this, and this isn't going to be that bad. In the following, V is the vertex, F is the focus, D is the directrix. 2 are given, find the third, and state the equation for the parabola, and we are also going to sketch it a little bit. Okay, so we've got a vertex of 4, 2, over 4 and up 2, and I'm going to put a little point there, and call that a vertex. Then I have a directrix of y is equal to negative 3. All y equals are horizontal lines, so I'm going to put a y equals negative 3. So, vertex, directrix. Now, I know that the vertex is halfway in between the directrix and the focus. So if that's my vertex and that's my directrix, my focus has to be up the same, which means that I now know that C is equal to 5. So I'm going to put a point up here, call that the focus, and then let's state the equation. My HK is given as 4, 2. Since it's going to wrap like this, this is going to be a y equals. So y equals a positive. So I'm going to go 1 over 4 times 5 because my a is equal to 1 over 4c, just like c was equal to 1 over 4a. If you do some algebra, you'll see that these two equations are equivalent. X minus 4 squared plus 2, because I'm throwing my vertex in. If I simplify that, I get y is equal to 1 over 20, x minus 4 squared plus 2. Most of our parabolas are going to be fractions that are less than 1. They're a little bit easier to work with when it comes to this type of system. I also want to introduce a new type of point, and I have a special name for them. But if we're looking at all the points that are equidistant from the focus to the directrix, we can also count over 2c units, meaning 10 units here. So if I go left 10 from the focus, I get a point right here. Now why is that a point on the parabola? Because it is 10 units away from the directrix and it is 10 units away from the focus. And what I have done is effectively create a square. I've created a square of 2c units, meaning that my parabola would actually look a little bit more wide like that. So I'm really only graphing part of it. I call these box points or square points. I tend to just call them box points. I'm going to refer to those a lot. Those are kind of optional points for some teachers. I'm going to ask my kids to require them. Those are just two more easy points to graph. Plus, it reflects the definition of a parabola, all the points that are equidistant from the focus as they are to the directrix. Okay, let's do the next one. I have number 2. Skip down. I got a vertex of 0, 0. So I'm going to put an ordered pair there. And I have a focus of 0, negative 4. I'm going to label one V and one F. So then, knowing that the vertex is in the middle of the focus and the directrix, I can put a directrix as a horizontal line. And that gives me directrix. And I now know a few things. I know that C is equal to 4, because that's the distance between focus and vertex, or vertex and directrix. I know it's down, so I know that A equals negative 1 over 4 times C, so 1 over 16. And I know that HK is 0, 0. So my equation, putting all this together, is y is equal to negative 1/16 x minus 0 squared, or just x squared, plus 0. So that's my equation for the parabola. Graphing the box points, which I want you to do on this particular one, we're going to look for down 8, then right 8. So that's going to put a point right about there. And then mirror that on the other side. And connect out. Number 3, we're going to do our first example of a different kind of parabola. I'm going to graph x is equal to negative 6, 1, 2, 3, 4, 5, 6, as a directrix. Right away, you know this is going to be a sideways parabola, because our directrix is now perpendicular to what it was before. The vertex, negative 3, positive 4, goes here, which means that my focus has to be the same distance apart, so that has to go here. Label this F, label this V. If I look at my C value, I know C is 3, which means A is equal to 1 over 12. It's positive because it's going to the right. This parabola is going to open to the right. And I'm going to use the different type. I'm going to go up here and look at the x equals 1. If I plug in, x is equal to, well, let me state my HK before I forget this. HK is equal to negative 3, negative 4. And I get x is equal to positive 1/12, y, now we're going with the y minus a negative 4, y plus 4, squared, minus 3. X and y switching this. So here's the equation for this. If you want to check this graph on your graphing calculator and you have the updated operating system, we can go to a graph and press Menu, Graph Entry, and Equation, Parabola, and I'm going to look for the x equals 1 that's in graphing form. If I pick that, then I can enter what I just had. I can enter 1/12, y minus negative 4. So they want you to actually fill in the HK, so we're going to put negative 4 squared, then negative 3. And you should see the graph there. I'm glad I did that, because now I look back at my graph and realize it's not going to match. I went up 4 instead of down 4, which probably some of you were screaming about when you saw this video. Well, I did that before I graphed, so I didn't get too far ahead. Vertex and focus should be shifted down. Didn't change anything else. My C values were still the same, and my vertex was correct in the equation. So now that this graph and this graph match, okay, I'm pretty safe. I can do box points, though. Let's do over 6 and up 6. Put a point here. And I got that one, and I won't have enough space on the other side, so I'm just going to carry this over here. And there's a sketch of a partial parabola. Number 4, let's plot 3, negative 2, and then 1, negative 2. Vertex, focus. So directrix has to be on the other side of the vertex, which means that it's going to be right here, coming down. My directrix is x is equal to 1, 2, 3, 4, 5. My c value is 2. This is a left-sided parabola, so my a is equal to negative 1 over 4 times c, or 1 over 8. Vertex is 3, negative 2, so I'm going to go x is equal to negative 1 over 8, y minus negative 2 squared plus 3. Reversing my x and y. Then for my box points, I can do 4 up, put a point here, and then put a point here. And trace. So that's a left-shaped parabola. And I'll let you check that on the calculator if you'd like. Okay. So that satisfies these conditions. This also said, if I kind of go back, we wanted to find the third. So I didn't quite finish that part. Focus for this one would have been positive 4, positive 7, labeled right there. Number 2 is missing the directrix, which is a y equals line at y is equal to positive 4. And number 3 is missing the focus, and the focus right here is at 0, negative 4. Okay, let's move on to some more complete types. So we have these that we have to graph, and like before, we're going to kind of limit the directions down so we can all do it in the same way. Part A says the graphing form of the equation. Part B is the direction of opening, which is up, down, left, or right. Part C is the coordinates of the vertex, h, k. The focus, whether that is up, down, left, or right. The equation of the axis of symmetry and the equation of the directrix. And finally, graph the parabola using intercepts. This G step is actually the longest step, as we're going to see, because we're going to need a lot of math to do it. We're going to find x-intercepts and y-intercepts, as well as all important parts. So, let's do this. Step A, graphing form is given. Step B, the direction of opening is positive, and so it's an up. It's a y equals, so it's up, down, and it's positive A, so it's up. The vertex. Vertex is 3, 2. Okay, I'm going to start graphing this over 3 up 2, and I'm going to put a V for vertex, so that now when I do focus, I know that the focus is going to be, let's put a little V there, should be up. So focus, I'm going to put the order pair 3, comma, but why did I put it up that far? Let's hold on that. I'm missing a little feature here. I have to figure out what my C value is. So let's kind of sketch up here. C is equal to 1 over 4A, which means A is equal to 1 over 4 times C, or 1 over 4 times 12, or 1 over 1/3, or 3. So I'm going to go up 3, knowing that my C value, sorry, that should be C equals, my C value is 3. Up 3, down 3. Up 3 for the focus, down 3 for the directrix. There's my directrix. So my focus is now 3, 5. Axis of symmetry I'm going to draw. I'm going to go vertically through the focus, through the vertex. And I get an x is equal to 3. Directrix is a y is equal to negative 1. And now we're going to take a look at what we have to get in order to graph this well. Now if I do a light little sketch, I'm going to see that I have no x-intercepts, so I'm not even going to try to plot those. You don't have to find the complex ones if there aren't any. I do want y-intercepts, though. So what I can do is plot the y-intercepts. I can plot the y-intercepts by saying y is equal to 1/12, 0 minus 3 squared, plus 2. 3 squared is 9, 9/12 is 3/4, so that's 2 3/4. And if I go 0, 2 3/4, I get a point here. And I'm going to reflect that about the axis of symmetry and put the other point there. I can also do box points to get another one. My C value is 3, so I want to go 6 to the left from the focus and 6 to the right from the focus. If this all works out, it forms a nice, neat arc. Connect the dots, and we're done. Let's do another one. Let's do an x equals. If I go part A, up, down, left, or right, it's an x equals, so it's left or right, and it's negative, so this has to be left. Let's see, part B. Oops, sorry, that was part B. Part A is the graphing form, and that's given, so we'll hold on that. And then C wants to know, I believe, the vertex. Yep. So the vertex, remember, in an x equals, x and y are switched. So this would be -4, +2. I'm going to graph that. And I'm remembering how I used to do this because I'm going to take a little sidebar here and start to figure out what my little c value is. C is equal to 1 over 4a, which is equal to 1 over 4 times, it's actually the absolute value of a. Oops, here comes the examine. Coming back, so 1 over 4 times 1/6, which is 1 over 2/3, which is 3 over 2, or 1.5. So I know that that's my C value. This means that now that I kind of can plot all this stuff, it's a left parabola. I'm going to go 1.5 units to the left for my vertex and put a focus, and 1.5 units to the right and put a directrix. Kind of being careful to go halfway through these points as best I can. That's the directrix. So, focus ordered pair, if I look at what's going on here, my focus ordered pair would be -1, 2, 3, 4, 5. Focus would be -5.5, comma 2. Now I'm okay with decimals here. If you're not, let's use -11/2, comma 2. My directrix, my axis of symmetry first. It's now a horizontal line because we're doing a left-right parabola, so let's draw that thing in. And that axis of symmetry is a y is equal to 2. Finally, my directrix is a vertical line at x equals, that's -2.5, or x is equal to -5/2. So get all that from the graph, and then we go to part G, which is by far the hardest one of this, because we have to get several points down. Now if I look at this, this also doesn't cross my y-axis, so I'm not really left finding roots of a sort, but it does cross the x-axis, which is what I get when I plug 0 in for y. So I'm going to go x is equal to -1/6 times 2 squared minus 4, which is -2/3 minus 4, which is really -4 2/3. So if I kind of plot that out at -4 2/3, 1, 2, 3, 4, -4 2/3 here, and then I put the side opposite the axis of symmetry. Finally, we can stick box points in. My 2c value is 3, so if I go up 3 here and down 3 here, I should have a nice set of ordered pairs to cross and to graph this with. Okay. So you have 16 problems. Good luck. Graph carefully, and I will see you guys on Monday.